All right, so this second question, it says that asymmetric bar shown in the diagram has weight of 7.6 newtons and center of gravity that is 0.04 meters from the wider end, on which there is a load of 3.3 newtons. So this is the wider end, this is the center of gravity, and there's this weight of the bar and its distance. The load is placed on the wider end. This load has a distance of 0.04 meters from center of gravity, and in fact, if I look at the pivot, this load has a distance of 0.04 plus 0.06 meters. So the total distance here should be 0.1 meters. Now this end has a force P acting on it, and this P force has a distance of 0.08 meters. So it says that to maintain equilibrium, what would be the force P acting? Now one thing that I know for equilibrium is that the anti-clockwise moments should be equal to clockwise moments. Equilibrium has two conditions. One is what I just stated, anti-clockwise moments is equals to clockwise, and the other condition is that the sum of all forces will be zero. So here I write anti-clockwise moments is equals to clockwise. Before I move on to write this equation, I first of all need to identify forces. I'll just label them. Let's say this is force P which is acting. I'll call this F1, and its distance from pivot, I'll call this D1 to make my work easier. Then this weight W acting from the pivot, I'll call this as F2, right? And the distance of F2 from the pivot is D2, which is given as 0.06, and then I'll consider the last force, which is the load F3, and I know that the distance of this load from the pivot is D3, right? Now this is done. One thing I know for sure is that if I apply F1, definitely it will make the bar turn like this. So F1 is causing what? A clockwise moment. If I apply F2, it will try to turn the bar like this. So this is causing anti-clockwise moment. And if I apply F3, it's going to turn the bar again this way. So this is also causing anti-clockwise moment. So now I know what are my clockwise moments, what are my anti-clockwise moments. For anti-clockwise moment, it's first F3 into D3 plus F2 into D2, then the clockwise moments, it's equals to F1 into D1. Now I'll just plug in the values. So it's F3 into D3. What is F3? 3.3 newtons. And what is D3? D3 is this whole distance, which is 0.04 plus 0.06. So that means it's 0.10 meters, plus we have this distance, this F2, which is 7.6 newtons of the weight, into its distance D2, which is 0.06. Then we have F1, which is this force and its corresponding distance, this one. So F1 is P, and it's 0.08. all right, now this is what I have to find. So I'll make this the subject. I'll do all the calculations. It would become 3.3 into 0.10 plus 7.6 into 0.06, that is equals to P, all this divided by 0.08, right? So here I calculate P, and the P will come up to be